Hey everyone, welcome to Challenge 5. This one was deceptively tricky at some parts, and so it's okay if this took you a longer amount of time, or if you didn't completely get the answer, we'll go over it together now. Like usual, I'm going to fork this repository to my personal account, and then I'm going to clone it locally. And also, like last time, because this worked really well, I'm going to go ahead and put the prompt side by side with the code, and then I'm going to copy in the example inputs so that I can quickly copy and paste into my program when I'm manually testing. Alright, and now let's have a crack at the problem here. Just like last time, our main method is already implemented for us, so we just need to fill in the functions for finding the mean and median of a list of scores. So this mean function is the easiest, so let's go ahead and start there. The average of a list of scores is going to be the total of all those scores divided by the number of scores. I'm going to create a variable called total, and I'm going to set it equal to 0 to start. Then we're going to iterate through all of the scores inside our list of scores, and then we're just going to add it to that total. And at the very end here, all we need to do actually is just return that total divided by the total number of scores, or in other words, the length of the list. And that's our first pass through. So I'm going to go ahead and write my changes, and then I'm going to open a new terminal here. I'm going to print out the test scores from earlier so I can just copy it, and then I'm going to paste in the first example into my executable program here. And as you can see, we get 63.6. However, if you look at the prompt, you remember that in the prompt, you're supposed to round down to the nearest integer. So we should just be printing 63. Now, how do we do that? There are two ways to do this. The first is by using integer division. If you remember in one of the very first videos, integer division is only going to give you the whole number of times that the second number goes into the first. And so you could change this to a double slash here. The other way to do it is going to be to just convert this entire thing to an integer, and that'll automatically discard the decimals. Great, if I write my changes and then re-execute this code, we now get 63 as expected. However, if we paste in the input for the second example, you can see that we get a mean of 94, and 94 is not 55. Something is wrong. You can see here that there's a score in there that's an invalid value, 252, and so it should have been discarded and not factored into our calculations. Let's go back and fix that. You can see here in the code that we're already iterating through every score, and so now we just need to add a check to make sure that the score is actually valid. Now, a score is valid if it's from 0 to 100 inclusive, right? And so we need to handle this in two conditions. If score is less than and equal to 100, and score is greater than or equal to 0. Okay, remember that and, it's very key. We want them both to be true to limit the numbers to between 0 and 100. Now there's one more thing we need to do. If there are invalid scores in the list, that means that the total length of the list is no longer the number that we should be dividing by. So what we're going to do here is we're going to have another variable that's a counter that keeps track of the number of valid scores, and then we'll count up by 1 every single time we encounter a valid score. So I'm going to write my changes, and then I'm going to go down here and, let me copy the input for example number 2 again, and then I'm going to execute my program. I'm going to paste it in, and I get 44. That's still not right. Duh. I made a variable, but then I didn't use it. Sorry. I forgot to replace length of scores with count. Now, if I replace that with count, and then I run again, now we get 55. Okay, good. And now we come to example 3. If I copy this input here, I run my program, and then I paste it in, we get a program crash. And the error is that we tried to divide by 0. Okay, yeah. So if we have a list of only invalid values, then we essentially have a total of 0 and a count of 0. And if you try to divide by 0, then the computer cries. So let's handle that scenario. I'm going to make use of my count variable here, which reliably tells us how many valid scores there are. All I'm going to do is a check here. If the count is still 0, meaning we have no valid values, I'm just going to return -1. Again, I write my changes, re-execute my program, pop in the 101, 101, 101, and then we get -1. Good. So we have officially finished implementing the mean function. Now it's time to implement the harder one, which is the median. If you remember, the median is a score that's in the middle. If you have an odd-numbered list, that's really easy because there's just one middle, but if your list is even, it gets a little bit harder because then you have to get the two middle elements and find the average of those two. Now, in order to make this easier, we're going to make use of the list's built-in indexing, right? But the problem with this is that we have invalid elements mixed in with valid elements. And so for the median, instead of just iterating through and checking if a score is valid or invalid, I'm going to actually construct an entirely new list that consists only of the valid numbers. I'm going to call this list valid scores, and then I'm going to copy the loop from above because we're doing the same thing here, but instead of incrementing variables, I'm just going to add the valid score to the list of valid scores. Once we have our list of only valid scores, here's where it gets interesting. How do we find the middle? Well, earlier I mentioned that we can use the lists or arrays built-in indexing, right? And so I'm going to create a new variable called middle, and I'm going to set it equal to the length of our valid scores, integer divided by 2. Now, let's take a second to think about this mathematically. If you have an odd-numbered list and then you divide that by 2, you're always going to get something 0.5, right? However, when you do the integer division, it rounds that 0.5 down to the nearest whole number or integer, and it just so happens that because we use zero-based indexing, that rounded down number is the middle element in an odd-numbered list. So yeah, a little bit of a mental workout for you in this programming challenge here. And so that middle index right there, we just need to return whatever element is that middle index for an odd-numbered list. But there's more that we need to do. Let's handle the scenario for an even-numbered list, okay? If the length of the valid score is divisible by 2, then we now need to fetch two elements. We need to have a lower element and an upper element, and then we need to return the average of those two elements. So I'm going to do lower is equal to valid scores of middle, which is our middle index, right? And then I'm going to do upper is equal to valid scores middle plus 1. And then I'm going to return, remember int to convert this to an integer and round down. I'm going to do lower plus upper to get the total of these two and then divided by 2. And that's the average of the two middle elements. And then for this final return statement here, I'm just going to return the middle score because if it makes it to this point, then we know that it is an odd-numbered list. All right, so I'm going to write my changes and then I'm going to execute my code and then I'm going to insert the examples that I've been doing. So if I paste in the first example here, I get a mean of 63 and a median of 75. Good, that looks correct. And then if I do the second one here, if I paste in example 2, I get a mean of 55 and a median of 80. That does not look correct. So, actually, here is a showcase of very rudimentary debugging. Debugging is just the process of trying to find problems in your code. There are actually better ways to do this, and there are actually tools for this. However, one of the easiest and quickest ways that you can quote-unquote debug your program is just by going in and then inserting print statements. So inside my code here, inside the section where we confirmed that the list is even numbered, I'm just going to insert a print statement and then print out what my lower and upper are. So I'm going to write that change, I'm going to re-execute my code, put in that input, and then I get that lower is 75 and upper is 86. Yeah, that's not quite right. And I know what the problem is. Okay, I'm going to insert a print statement again to print out the list of valid scores so that I can show you. If I write these changes and then re-execute the program and then put in the input again, you can see here that my list of valid scores is these 4 values right here. And what I've mistakenly done is I've labeled the upper middle element as the lower, and then I've fetched one more element higher than the upper. And so I just need to go back into my code and adjust this. I don't know what I was thinking when I was working this through, but the middle index for an even list actually points to the upper middle, and then we need to fetch middle minus 1 to get the lower. Okay, and then after making these changes, I re-execute the program, put in the input, and now we get 55 and 56. That looks correct. Of course, we have example 3, again, the invalid scores. We haven't handled this, so I can tell you right now the program's probably going to crash. And it crashed, okay, yep. And so what we need to do is we need to go in and do the same thing again. If the number of valid scores is 0, then we just need to return -1, right? Now, we don't have a counter here, but we don't need it anymore because we literally collect the valid scores into another list, and so we can just check the length of that list. Write my changes, execute my code. Hopefully you're getting accustomed to this by now. And then if I input 101, 101, 101, we get -1 for both mean and median. Good. Last bit of cleanup here, I'm going to go back into the code and then I'm going to get rid of those print statements we inserted earlier to debug, and I believe this fulfills our requirements. Let's double check by executing our test suite. Ran 4 tests, okay. And that completes our requirements for challenge 5. And now, remember, get into a habit of doing this as well. We're going to check which files we changed with git status. We're going to add the files we want to finalize these changes for, and so this is just going to be mean median.py. Write a commit message, everything looks good, and then we're going to do git push. And there you have it. Hopefully these solutions videos have been useful and helpful for you so far. You wouldn't think that calculating the mean and median of a bunch of test scores would be tricky or difficult, but if you're new to programming and you're not used to thinking in this way, sometimes you encounter those tricky challenges that really require just more practice and experience. And that's why we have these programming challenges. They're meant to give you that practice. They're meant to help you think more like a programmer, to think more like the computer would when it's running all of these instructions that you're writing. Great job. I think that's enough about lists for now. In the next lesson, we're going to talk about another data structure called dictionaries or maps. See you in the next lesson.